So let's review how to solve logarithms. So taking a look at this problem right here. So I notice on the left side here, we have two logarithms, okay? So typically we want to condense these two logarithms into a single logarithm, okay? So using our log properties, I can rewrite this as log base 3 of x plus 1, right, times 2x, right? Is equal to, we have 1 plus log base 3 of 4, okay? Now, since we have this log on the right side as well, what I'm going to do is I'm going to move it over to the left side so that way I can condense the logarithms into a single log. So I'll have log base 3 of 2x times x plus 1, right, minus log base 3 of 4 is equal to 1. Okay, and then I'm going to condense this into a single logarithm. So using the log properties, I have log base 3 of 2x times x plus 1 divided by 4 is equal to 1. Okay, so now that we have it written as a single logarithm, right, what you want to do is once you have it written as a single logarithm, you want to change it to exponent form. Okay, so in exponent form, we know this is going to be 3 to the first power, right, is going to equal 2x times x plus 1 divided by 4. And then now we just need to solve for x. So 3 to the first power is 3, multiplied by 4 on both sides. So I'm going to end up with 12 is equal to 2x times x plus 1, right? And then we've got, let's say I'll distribute, I'll get 2x squared, right, plus 2x, right? It's going to be a quadratic, so I'll set it equal to 0, so I minus the 12 to the other side. And I can take out a factor of 2, right? So that would give me x squared plus x minus 6. Looks like it's going to be a quadratic, so we're going to factor this. This would be x plus 3, x minus 2. So we know that x plus 3 is equal to 0, x minus 2 is equal to 0. So x is going to equal negative 3, and x is going to equal 2. All right. Now, whenever you're solving logarithm problems, it's very important for you to double check that your solutions, right, are valid, right? So we have x equals negative 3 and x equals 2. So if you go back to the original problem, remember, we have to plug in these values. Like for example here, if I plug in negative 3 here for x, this will give me log base 3, right, of negative 2. Now remember, this is undefined. This value here cannot be 0 or negative, right? So if you have a negative here or 0, that means that we need to reject this solution. So we know that negative 3 needs to be rejected. Now if you plug in 2 into all these values here, it looks like it's going to be perfectly fine. So the 2 verifies, but the negative 3 solution doesn't. So negative 3 here, we would reject this. When we check the 2, 2 was fine, so x equals 2 is our solution. Okay? All right, so let's take a look at the next example here. So once again, on the left side here, it looks like I can condense this, right? So I can use the log properties, right? So we're going to get log base 2 of 2 times 2x to the second power, right? Because remember, if this number is in front of this log, I can move this back here and it will become the exponent of 2x, right? Is equal to, we have log base 2 of x plus 1, okay? Now, whenever you have a log, right, equal to another log, right? So on the left side, you have a single log, and on the right side, you have a single log. Basically, what that means is this part here has to be equal to each other, okay? Because we have log base 2 and log base 2 here. So that means we can equate these two parts, right? So when you have a problem like this, once you have a single log equal to another single log, and if those logs have the same base, you can just equate these two parts. So we can say now 2 times 4x squared is equal to x plus 1, okay? So this is going to give us 8x squared. Looks like we're going to get a quadratic, so I'm going to set it equal to 0. minus x minus 1 is equal to 0, right? Now typically you would try and factor this, but I can tell right away that you're not going to be able to factor this right here. So you can't factor this quadratic, right? So we know that we're going to have to do the quadratic formula here since we cannot factor this, right? So x is going to equal, so this would be your a, your b, and your c, right? This is like negative 1 for your quadratic formula. So we have negative, all right, b is negative 1 plus or minus the square root of b squared, so negative 1 squared is positive 1, minus 4 times a, which is 8, and times c, which is negative 1, all over 2 times a, which is 8. All right, so if we work this out, we're going to end up with 1 plus or minus. We've worked this out right here. Basically, inside the radical, we'll get 1, and then that'll give us plus 32. So we get the square root of 33 divided by 16. All right, so basically we have two solutions here, right? We have a 1 plus square root 33 divided by 16, and we have a x is equal to 1 minus square root 33 divided by 16. And what we want to do is we want to put these values in the calculator. All right, let's find out what we would get in the calculator. So if we put them in the calculator, we would end up with, let's see, x is going to equal 0.422, and over here x is going to equal approximately negative 0.30. All right, so once again, we want to double check our solutions. So we've got 0.422 and negative 0.3. So if we plug them into the original problem, right? So we know we can't plug in a negative right here. If we plug in a negative right here, it would make this value as negative. So we would reject, all right, we're going to reject that solution. Now, if we plug in the positive value, it looks like this would be positive and this would be positive. So the positive value is perfectly fine, okay? So we're going to have to reject this negative solution. So we would reject this, right? And we would accept this solution right here, okay? All right, so let's take a look at the next solution. All right, so this time we have a natural log. All right, we have a natural log here. So now a natural log, basically you do everything the same. The only thing different is the base of the natural log we know is e, right? So first of all, I see a natural log on the left side and a natural log on the right side. So I'm going to get them together on the same side, so that way I can write them as a single natural log. So this would be natural log 3x. I'll minus the natural log 2 to both sides, and then I'll add 2 to the other side, so I'll get negative 1 on this side. So now I can combine these two natural logs using our natural log properties. So this would give me the natural log of 3x over 2 is equal to negative 1, right? So once we have it written as a single natural log, we'll change to exponent form. Now remember, the base of a natural log is always e, so we have e to the negative 1 power is equal to 3x over 2, right? And then now we just need to solve for x. So we're going to multiply by 2, divide by 3. So 2e to the negative 1 divided by 3 is going to equal x, right? And then we just put that in the calculator. So x is going to be approximately, if we put that in the calculator, we're going to end up with, let's see, 2e to the negative 1 over 3, 0.2453. So approximately 0.2453 will be our solution. Okay? Oh yeah, once again, let's just verify our solution. So if we plug this value into the original problem for x, it looks like this will be positive here, so we know it's a valid solution. Okay? So anytime you're solving logs and natural logs, always verify your solutions to make sure none of them result in a negative value, right, that would make your log undefined.